Hi, everybody. So please welcome our next speaker, Bangert.
Hello, everyone. So today I'm going to be talking about dispatch magic. And I was kind of conflicted on what to name this talk. So I just went with the shortest name that sounded somewhat interesting, and I realized in retrospect, all the other talks at the same time are extremely descriptive and tell you exactly what you're going to get, and that doesn't tell you much at all. We are going to be talking about web framework dispatch. And this is an underlying part of all web frameworks, and it's sort of a meta talk, and I've always felt that there needs to be more meta talks in the Python community, and not just, here's how you do this with Django, or here's how you do this with Pyramid, which there's lots of, and if anybody's been around for the previous talk in here on Pyramid auth, that's sort of what that was. This is more, what do web frameworks actually do? What are the fundamentals behind them? And when you understand these fundamentals, it becomes really applicable. You can look at other frameworks in totally different languages. Lost the mic here? Okay. You can look at other frameworks in totally different languages and have no problem, well, besides for the new syntax, of course, figuring out sort of, okay, this is what the person that made the framework was thinking, this is how they wired things up, and this is where everything goes. And seeing this big picture, well, it's not very common in the Python world. Everybody explains their framework, and there was one page for a long time on the Python website where it would go over some of these big things, templates, and they have controllers or views, and there's all these different terminologies they throw around. So this sort of goes over several different common paradigms for how web frameworks do dispatch, and some of those popular ones. And hopefully, once everybody knows these, then it'll be trivial to change frameworks, explore new ones, or determine whether or not you're using something that's best for what you're actually doing. First, of course, it's useful to know what exactly is dispatch. Obviously, it's a main part of the web frameworks. Dispatch is the thing up front. It's really where the request comes into your web stack, and the framework does the dirty work of figuring out, do you actually have code that can be called with this request? Or should I determine, however I'm going to determine, what kind of error we're going to start throwing back to the person that's actually hitting your website? So dispatch is the critical part. It's the request handling and how that maps to your code that you actually write. Because, of course, people don't want to write all this code that does all this stuff. I mean, that's a lot of repetitive work. Frameworks already do that. So essentially, the overall picture is you have an HTTP request that comes in. It has a bunch of attributes attached to it, your headers, what kind of request it is, and then, of course, the body of it. In the Python world, that generally goes into a WSGI call nowadays. So everybody runs a web server that in some way talks to usually a WSGI stack, and that's where it hits the Python layer. So there's something usually up front. It might be Python itself that takes that rather boring thing and turns it into a call to your code. And the important part right there is highlighted. It's going to turn into a call on your code. Maybe it's a function, maybe it's a underscore call inside of a class. Whatever it is, it's going to call it with environ and start response. Now all those headers, of course, have already become keys and values inside of environ, and you have a start response that you can respond with. And this is sort of the dirty underlayer of what's going on. We're not going to talk much about that, though, because we're using web frameworks. So we're going to talk about how web frameworks make that task of turning what that happened right there with the environ call and the start response and all that stuff, and made that go nicely to your code. So the way the frameworks usually do that is they let you define some sort of mapping on URLs. And in this case, if anybody's used Django, some people might have used that. It's, yeah, a little popular sometimes. I'm going to give a lot of Django examples, and we're going to read some Django code, so that'll be fun, because everybody's read Django dispatch code, I assume. No? We have a URL patterns. We define regular expressions, and we'd say which callable they go to. So it goes to a function inside of a module somewhere. And Django goes and pulls all that out, and it puts together a system that allows it to figure out that this whole WSGI thing went in through here and then went to your nice little function. So you don't have to write any of that other stuff. You just declared which URLs go to your functions. Very simple. That's really the core of what a web framework does. Web frameworks fundamentally turn requests, as they come into the entire stack, into a system that goes to your code that's then called. The most popular system that matches URLs and actually gets to code that you're going to write that will then handle it is generally called URL matching. Different people call it different things. Regex URL matching. Django has several names inside the classes that they use for it that we'll look at. Django's system uses regular expressions. So here's a whole group. You have a bunch of regular expressions. They go to a whole bunch of functions. And that's the way many people are familiar with it. Of course, many people don't like writing regular expressions. They can be kind of annoying to write. Writing all the capture groups especially can get pretty annoying. So a lot of frameworks have regular expression abstractions. So you don't want to write the whole regular expression, that's fine. You write something a little nicer. This is out of a Pylon's application. This is not exactly the way I would write it, but this is the way Reddit has it. So it's a very large website that's actually in production, and here's a little bit out of it. You can see the highlighted places, those are the capture groups. So instead of writing a very obtuse regular expression to match and extract that section, we just write this, and okay, it gets pulled out. Now, of course, this isn't free. It's somewhere the framework has to take this, interpret it, and make a regular expression, which is what they usually do. Rails uses regular regex abstractions. So when you're familiar with these techniques, you can just go to other languages and go, okay, you're using this, and I can see how that's going to happen. And then where does that code go to? And you can see, oh, well, it's going to go here, it's going to go there. It's definitely the most popular form of resolving requests I've seen. In any language you use, generally one of the most popular web frameworks is going to use URL matching. It usually leads to a single callable, and it usually results in a single list of valid URLs for an application. So when you have this list, you can go through it all and you can go, okay, well, here are all the URLs that are going to go somewhere on my application. Now, this isn't necessarily definitive. I mean, there's ways that you can map it to some other function that's then going to do something totally crazy with the request. Or maybe it's going to translate it and do RPC. So, if anybody's ever used Piston, they do something like this. So you write your stuff a little bit differently, and it handles a different type of dispatch based on if it's a get or a post or any of that kind of stuff. So here's a fun part. We'll go ahead and take a look at how Django does dispatch based on what we just saw here. So this is straight out of a wsgi.py file, and it's inside Django core handlers, in case anybody likes reading source code in the Django tree. And this is the wsgi handler. So here we can see Django's going to do, okay, we have a, is this big enough for everyone, by the way? That work? Okay. It's going to translate this wsgi call, it's going to go through, and then importantly, down here, it has a bunch of response headers, it does start response, it does all of that stuff for you. But we can see right here, kind of important, we have request equals request class, and then it's going to get a response. Or if there's some problem, it's going to return a bad response. So this is what frameworks help you with. They do all of this little work, and they make sure that if problems arise, or if your function explodes, or if there's something else wrong with the request, you don't have to deal with it, the framework does that for you. And then importantly, it dispatches to your code. So to do that, it calls getResponse. I already have this open, so we can see getResponse too. So right here we see getResponse. It goes through. By the way, in case anybody ever wonders, is my framework fast enough? You can learn a lot by how efficient a framework is by reading the code that does dispatch, because every single request has to go through this process. And if it's a really long process that involves function call after function call after function call and instantiation, it can get slower. In this case, you can see objects being instantiated. It's going to make a regex URL resolver. This is, some of the secret sauce here. This is where it gets down and it actually figures out, okay, you wrote URL patterns. How do I get that to your code? And we can see there's a whole bunch of stuff, lots of error handling, lots and lots and lots of error handling. And eventually it needs to call resolver.resolve. So let's go ahead and take a look at our regex resolver. There's a regex resolver. So we saw it made one of those. We can see that puts together a whole local regex that inherits and does a whole bunch of other stuff. It has to, of course, turn all those URL patterns into things that it can match. So there's a fun little function there for that. Yeah, if you count indentation. I don't mean to pick on Django here. Trust me, there's heinous stuff in every web framework. Amen. Yeah, we are not innocent in Pyramid either. Every framework has its heinous stuff. Here's our resolver method, though. So it's going to do a regex search. It's going to go through all the patterns that you have, and it's going to look for one that matches and resolves. And then it returns a response, and the response goes back out. So once you get down to the nitty-gritty of it, it's not that big of a deal. You know, you have to look up some of these things and see where they go to. But overall, for the most part, you can get through the big chunk of it in just 3, you know, modules. So it goes pretty quick. Another common, well, not terribly common actually in the main world, but this is where we start getting a little bit more unique, I think in many ways, on what Python offers, which is Python has had so many web frameworks that we seem to have more or less implemented every single type of dispatch known to mankind, invented several of them, and then, as if those weren't enough, implemented the same ones 3 or 4 different ways. So for object dispatch, one of the easy ones that's a very common one is CherryPie. And this is one that if anybody ever used TurboGears, this was used underneath TurboGears. And if you've only used Django, this might be a little different. You don't write regular expressions. So if you really have an aversion to writing regular expressions, you might want to look at CherryPie. It can be kind of neat on that. Instead, you write your code and what it returns in classes. And then when you run the CherryPie engine, you go ahead and pass it an instance of your class. And when it dispatches, what it does is it looks for methods or attributes on the class for every chunk of the URL that is considered exposed. So here we can say index exposed. And index is kind of a special case that it returns just for slash. So if you hit this website at no URL in particular, just slash, you would get hello world. So it's very, very short. It almost seems strange sometimes when you see how short this is that you'd want to add all the URL routing, but that, you know, it gets very popular. So if you're looking at Flask or CherryPie, you might want to try out CherryPie sometime. There's some fun things in there. If you want a little bit more complex example, you go, okay, well, I need 1 URL down. So here we have hello world, and we have 1 page, and we have our index. So what happens here is that if you had a URL that was slash one page, it would hit that 1 page there, and it would pull up the other one and go to the index there. So essentially, you just assemble your classes together, and you pass it an instance, and you're done. This can be very powerful because you can, of course, do all sorts of clever Python tricks, and you don't necessarily have a clean mapping of all the URLs and where they go to anymore. You have classes, and it sort of goes through them all. So it mixes your callable code into the URL resolution. So as you have the code that actually handles a request, that's actually navigated by the framework, CherryPie, to determine whether or not you can handle the request. If it gets down there and it can't find anything, then it might return a 404. The generic matching, as I said here, is performed by a special method name. We have the index. Generally, I consider it very easy to understand. It's a lot less work in many cases. You don't need to write URL patterns anywhere. This makes a lot of things very nice, and I think it's why TurboGears was very popular. And I should say it still is very popular among the people using it, of course. So I'm going to spend a little bit more time on this one because this is a big one. Traversal is a system used inside Pyramid. And it's a different system entirely in many ways. It works fundamentally different, I found, than almost any other framework in any other language that I've seen. Some of them have some crude attempts at object dispatch, but not really for the most part. So what the framework does in the case of Pyramid is it's going to split the URL into chunks. And it's going to run a very simple little algorithm. I'll let y'all read that for a second. So the path info, of course our path, we split that down, that's cool. We have a root object. That's sort of like what we just saw with CherryPie. You had a class that was sort of the root object. It then looks and goes through the list of URL chunks and it sees, can I split this anywhere? And then it calls get attribute on the next portion and it pops another portion off and it goes around like that in a little circle here. Get at him. So it uses a root object to navigate. Here's what one might look like. You could declare ACLs on them. It does access restrictions, but that's all, again, the framework. That's not necessarily related to dispatch, except in determining what code can't run if they don't meet a requirement. And this is a case out of one of the applications I wrote. So in this case, you could see that at the very least with this root object, the only valid URL is v1. Because what happens is it's going to take that URL that in this case says v1, it's going to split that, and then it's going to call get item with that first portion. Whatever comes back from this is going to call getItem on the next portion if there is any more. So in this case, it just returns v1, which returns another object. And maybe it goes farther, maybe it stops with just a QE version 1 API object. Now, if it stops right here, just at v1, then the context would be QE version 1 API, and that would be used to query. But I'll get to that in a minute. So the object that's returned at the end of the URL or key error is when traversal stops. And the resulting object is used for view lookup. So what is pyramid lookup? That's where it gets fun. So first you have to register all your views that are callable. Now this works exactly like it does, well, no, it doesn't work exactly like Django, but you do declare things. You have to map them. So in Django, there's little layers. I don't know if anyone's seen, I think it's digit or something, which makes Django a lot smaller, really small, and you can use decorators, sort of like with Flask. You can do that sort of with pyramid by using a decorator. Here's an example of it. So in this case, our functions look very, very similar to what we had for Django, except that we have a new one on the front called context, which matches an object, or a class of objects, or an interface, but I'm not going to get there either. When we match these, you can see right here that I'm not matching any particular URL. I mean, there's no URL matched in the traditional regular expression way. I'm essentially just saying that these functions should be registered as views that are going to handle requests where the context is an application and the request method is whichever one of these. So this gets us several easy abilities that can be a little harder to replicate in other things. If you're using Django or one of those, there's decorators and some other stuff that allow you to, if you wanted to, only have something called in certain cases that are very programmable. It can be a little bit more hairy. You have to provide, I want the request method this, etc. There's some easier ways to get in there with pyramid where you can declare all this, but the part where it gets kind of different is if you have Rails, if you have Django, if you have any of those, you saw at the beginning that we had a list of regular expressions and we had a list of functions. There's a very clear one-to-one mapping. And that's amazingly common, as I mentioned, in every single framework. So in Haskell, for instance, there's a web framework, and you make a list of regular expression-like things, and you put functions to the side, and it does the same thing. In Pyramid, it works a little different. Instead, when you register a view like this, it goes into essentially a small database. It's called the registry. And what happens is that when Pyramid gets a request, it looks at it, it goes ahead and goes through it a little bit, maybe it goes through as traversal, and what it does is it essentially gets a bunch of attributes that it's then going to query the database with. So here's what a small section of the database might look like. You can see there's a whole bunch of different contexts, and if one of these matches them, and then which callable it goes to. Sometimes the single context might go to multiple different callables, so this is also different. It's not a one-to-one mapping. You might get 3 or 4 different ones, and then it's going to have to choose which one is actually going to be called based on other parts of the request. It might even be completely custom and have a view predicate, which I left off here, and might have to run functions. Now, if anybody's used Pylons 1.0, this isn't terribly unfamiliar. You can write preconditions and functions that have to execute to determine if it's valid or not. The only difference in this case is that you can have a whole bunch of them, and it can go through multiple ones of them, deciding which ones it can actually call. So once it does all this, it has to determine the best view. And then it finds it, and then it calls it. So here's what our application looked like earlier. Here's a small Pyramid application. This is all open source under Mozilla in case anyone wants to look at a really small Pyramid application that uses Traversal. It's extremely dynamic in the way it's dispatched because all of the configuration is live and comes out of Cassandra on the fly. So there's no set base of what URLs are valid. Instead, it's just sort of like a map of what the available URLs are that will work. So we have a single file, and that's all that it runs. And it scans for all of our views. So here we can see some views. I showed a few of them earlier. You can see they're pretty basic. You have a queue list. You have a create queue, and they take a request, and they return little dictionaries, and it's very simple. This all runs just a JSON API thing, so it's not doing anything else. But it's a very small, simple thing, and the entire framework can locate and figure out what to call very easily based on what the context is. So this is just the code that I wrote, though. How does the framework actually figure out which one of these things is going to be called? Well, it's pretty easy, depending on what your definition is. We come in here, and we call getItem on our 1. We have v1. It goes down. It returns a QE version 1. What are the options? Well, that name can be anything inside of app names, and it returns an application. So here you can see when you have an application, that's going to be a context that maps in here. Now, since all of these are merely registered in a database, you can do really neat things. You can, of course, import other packages entirely that might register additional views for you in the view database. This makes it very extensible. But essentially, the brunt of the matter is we go in here, we figure out which one we're going to go to, and then it navigates down. And there's a little documentation here that shows you what requests you can make. Get, post, all of that kind of stuff, and put. So those are what I would consider 3 of the main dispatch choices that you have available to you in the Python world. You'll get a whole bunch of them with just Flask and Django. And definitely I would say that Python has the greatest variety in how a request is dispatched. You can find a whole bunch of different mechanisms. Other frameworks have some very unique things that they introduce as well. But I think with Python, you really can get a taste for everything. You can find continuation-based frameworks. You could find all sorts of crazy stuff. And I would highly recommend that everybody should give Traversal a try. And remember, use the best dispatch for the job. It's not always going to be easy to figure out what that might be, but once you get down to it, they all work fundamentally differently, and knowing which one is which makes everything a lot easier. Thanks. I have time for some questions, I think. Yes, no? We have time for questions? Yeah? Any questions? If you have a question, you can go up to one of the microphones.
Does Traversal necessarily lend itself to something like ZODB and just doesn't work with a SQL? And likewise, does SQL kind of push you in the direction of URL dispatch?
I don't think so. I mean, my application that I demonstrated there loads everything out of Cassandra. So, you know, it's really just calling getItem on everything. It definitely lends itself in some ways to, oh, I'm sorry, I haven't repeated the question. The question was, does the dispatch lend itself to ZODB or these other ones? I would say not necessarily. It's definitely easier with ZODB because it natively supports the getItem, so you can easily have things go down without having to implement that yourself like I did here. But implementing it here I don't think is too big of a deal. I mean, I have a fairly easy way of going in here and I pull out whether or not there's any farther that it can navigate down to based on where it's been, and then I just return objects. Some people have plugins that allow you to do essentially the same thing with SQL Alchemy. So you can load information out of SQL Alchemy and use Traversal fine with that as well. Thank you.
So Django has the reverse operator for making views more DRY, and that has always been kind of magic to me.
Yes.
I was wondering if you could speak a bit to how reverse actually does what it does.
The reverse one? How reverse does what it does?
In particular, because it seems to have to reverse engineer the regular expressions, and that was the piece that seems magic.
Yes. So there it is right there. And it definitely gets, yeah, URI. I've looked through some of it before. I haven't looked through it in depth, so I can't answer that specific question. I was talking with Alex Gaynor yesterday, and he was saying that was a pretty amazing little piece of machinery there that reverse engineers it and reconstructs it again. That is definitely, I would consider, one of the advantages of presenting a regular expression abstraction. Besides for making it easier to write them, it makes it really easy to generate URLs, which then doesn't require the reverse engineering.
And does Traversal have a similar reverse mechanism or sort of a counterpart?
It does. So with Traversal, what you can do is I don't know if my particular example has it, since we don't need to generate URLs in this one. But in Traversal, what you can do is with every resource, as they call it, you can put on, as it goes down, a parent attribute with the name of the parent. And then you could say, generate a URL for this context, and it will then follow the parents up to generate a URL for you.
Thank you.
Sure.
You mentioned sometimes you can be worried about the performance as soon as these things get really nested, or as you're doing more object creation lookups. How much is that? How much have you found that that's actually a bottleneck? And it seems like there's cool things you could do with this, like find the tree, which would require the least traversals as you're going through the regex or something, or favor lookups to more commonly used routes or something like that. And are those things used in practice?
I'm sorry, can you repeat the question?
Sorry, as performance of the, it seems like these are organizational things, and that seems like the right thing to think about. Is performance a thing worth thinking about?
The performance absolutely matters. Chris McDonough has done an amazing job on Pyramid, going through every single one, trying to avoid every single extra instantiation possible during a request map. And I believe the call stack, last time it was benchmarked, was, if it gets just to your basic hello world, was only like 20 function calls, which is amazingly short, because I think we easily went through more than that on the way through Django. And it's making objects that have hierarchies as well, and those all have extra costs. And Django, I think, was around 100 and something function calls by the time it gets down there, and that definitely adds up. More so in CPython than PyPy, of course. In PyPy, a bunch of them will be JITted, and it won't be as big of a deal. So you'll probably see a bigger gain on performance moving to PyPy on Django than you would on Pyramid for that very reason.
All right, cool. And are there ever things done like saying, oh, it looks like this one gets hit more? I remember I've looked at the very first release of Bottle. It has this interesting bug where it's reordering the routes table based on who you hit. Whatever gets hit most, there's a chance it will move up in the routes table and make things more efficient. And that seems like a bad idea, but are there good ideas like that are used?
There are. So one of so the question was, is Bottle doing something? They got rid of it. They got rid of it. Okay. There's definitely optimizations that can be made. I've seen one framework that when you declare all your URL expressions, it makes a strict set of rules about what they can be, and it actually orders it into a tree. So it actually splits down as much as it can the regular expressions, makes them into a tree, so that way it only has to navigate down through the tree rather than matching against a list. Obviously, if you have a huge list and somebody figures, if you have 700 or 800, or if it's a really big application and has, 4,000 valid routes, generally that's all in a list. If somebody keeps hitting a URL that's at the bottom of that list, it has to go through and match against every single one of them. That is not cheap at all. It can get really, really expensive. And if, I'm surprised some people haven't gone on GitHub to see whether or not they can denial of service somebody just by hitting the absolute worst case scenario as much as possible. Because lots of people do have a lot of their applications online. So there's definitely ways to make it more efficient. I would be somewhat worried about caching something like that. I could see why they would remove it, because there's other cases where maybe another condition was in there that if they just match immediately, it's not going to catch that one. I tried to do something similar like that in routes, and it didn't work out very well either, and I had to go back to not doing that. But I'd say the tree route definitely is the easier way to go if it can be split and separated to go down that route.
So actually, just a clarification on that prior question. The registry is only instantiated once when the application starts, and not every request, right?
In Pyramid?
In Pyramid.
Yeah, it's
right.
during the, right, it's right back. The registry is all set up right here. At the end of this, when it makes a WSGI app, it's done.
That's what I wanted to say. I mean, you don't do that expensive computation all the time.
Right, and it's always, the pyramid approach on a lot of this is always better to take a slightly larger hit up front and put together as much as can be done so that all the other requests later on will be faster. No problem. Any other questions? No? Okay, thank you.